From learning room, is that Bhaskar there? Hello? Hello? Who is in the learning room? Sanjay, how are you?
Good, ma'am.
We'll just wait for 5 more minutes for others to come. Otherwise, we'll start. So, Sanjay, you start doing this meantime as people are coming. You can start doing this question.
Yes,
Vishal, you also try. Vishal, are you able to do it? Hello? Sanjay, are you there? Yeah.
yes, ma'am.
What is the answer for the first one?
B.
Answer is B. Vishal, did you get the answer?
You must be doing, ma'am. 2 minutes. Doing, ma'am. 2 minutes.
Okay, okay, do it. So T is equal to 2.303 by K log of A0 and A by A0. No, A0 by K. So it is A0 initial concentration by final concentration. So if I put the values, it will be
Ma'am, it is
2.303 by
option B, ma'am.
10 raised to minus 3 log of 100 by 25, and that comes to 1386 seconds. Now do the next one. Do the next one. Did you get? Now the question says, A plus B giving C. Okay, A plus B giving C. So when I double the concentration of A, it increases, the rate increases by 4 times, right? So doubling, if it increases by 4 times, what is the order of reaction with respect to A? R is equal to K, A raised to then 2, because it is becoming double. When I double the concentration of A, the rate becomes 4 times. So the rate becomes squared. So it is second order. And when I double the concentration of B, the rate only becomes doubled. So it is first order with respect to. So what is the overall rate of reaction? R is equal is 2 plus 1, not R, the order of reaction. So overall order of reaction is how much? Order is equal to 2 plus 1, that is equal to 3. So the answer here was B, and here the answer is 3. Now let us take one more question. See, Vishal and Sanjay, only 2 of you are there, right? And if you are planning to leave the class in between, you must tell me. I will not continue to teach, because Sanjay, you generally leave the class before the end of the class. So if before leaving, you should tell, ma'am, I'm leaving.
Yes,
Vishal,
ma'am.
did you understand? If you are
Yes,
not
ma'am.
going to continue till the end of the class, you have to tell me, ma'am, I'm leaving. All right. I don't want to teach a class where there are no students, because anyway, I will not know, your camera remains
Ma'am,
closed. Okay. So
ma'am,
please.
ma'am, today I'll
Yes.
not be able to attend after 7, ma'am.
Today is the last day of,
No, ma'am, I'll not be able to attend after 7, ma'am.
I didn't understand. Can you say it again, please?
No, ma'am, I'll not be able to attend the classes after 7 today, ma'am. I asked for parent teachers meeting, ma'am.
Oh, till 7 today you have to leave at 7, right?
Yes, ma'am, yes, ma'am.
Okay. And what about you, Vishal?
I'll be attending full class.
Oh, okay. So now you see, half of the first order reaction is half life of the first order reaction is 1 minute 40 seconds. Calculate the rate constant. Can you do it? Both of you, please try to do the question. So the formula is T half is equal to 0.693 by K. So what will be T half? T half is half-life. So it will be 0.693 by K. Instead of K, what will I write? 1 minute and 40 seconds. So let us convert 1 minute and 40 seconds to how many seconds? Total how many seconds will it be? Vishal, can you tell me? 1 minute and 40 seconds is equal to how many seconds?
It's 110 seconds.
Why 110? 1 minute is how many seconds?
60, mom.
60. And 60 plus 40 is how much? 100, isn't it?
Oh, that's good.
Yeah, so it will be 0.693 divided by 100. So what will it be? Which option, 1 or 2? Tell me. It has to be option because it is a half-life of the first order reaction, seconds. So answer is this. Answer will be in seconds, isn't it? It cannot be T
Yes, ma'am.
minus 1, even if you don't do the calculation. Then the next question, in a reaction A plus B giving products, rate is doubled when the concentration of B is doubled, and the rate increases by the factor of 8 when the concentration of both the reactants A and B are doubled. Rate law for the reaction can be written as, so rate is doubled when the concentration of B is doubled. So same way can I write the rate law? Rate law will be K, and when the concentration of B is doubled, the rate of reaction rate is doubled when the concentration of B is doubled. So with respect to B, it is 1, right? And the rate increases by a factor of 8 when the concentration of both the reactants A and B are doubled. So what is the rate law? You look at these. When I increase both, so what will be the answer? Can you tell me? See, if you look at the first one, there are two ways of doing this question. Okay. So I put, it's increased by a factor of 8 when concentration of both the reactants A and B are doubled. So if I put here, if both A and B are doubled, so 2A, 2 raised to 1 and 2 raised to 1. So it will increase only 4 times. So this is not the correct answer. Here it is 2 raised to 2, 2 into 2 into 2. So that is equal to 8 times. And with respect to B, it's already unimolecular. So this one. Okay. So this is another way of doing it. You just apply the answers and see. Why can't it be C? Because in case of C, the order of with respect to B is given as second order. However, the question says that when B is doubled, then the rate is also doubled. So with respect to B, it has to be 1. So with respect to A, it has to be 2. So answer is 8. Now look at the next one. The rate of reaction decreases with passage of time as the concentration of reactants decreases. Which statement is correct? Hari Raghav has also come. Good. So the rate of reaction decreases with passage of time as the concentration of reactants decreases. There's a spelling mistake here. Okay. So rate of reaction is same at any time during the reaction. Rate of reaction is independent of temperature change, and rate of reaction decreases with increase in concentration. Can you tell me which is the correct answer? Hari Raghav, can you tell me which is the correct one? What does the rate of
1 minute,
reaction
ma'am.
depend? Which one? Which one?
1 minute, ma'am.
Answer is 1. Correct. Okay. So rate of reaction decreases with passage of time as a concentration of reactant decreases. So answer is 1. Now the next one, which of the following expressions is correct for the rate of reaction given below? Okay, look at this one. Which of the following expressions is correct for the rate of reaction given below? Tell me. So, Br minus. So, which is the correct expression? Rate of reaction with respect to Br is 5 times no is, see what you should write here is 1 by 5. It is comparison of Br and H plus. Okay, so the rate of disappearance of so rate with respect to Br, it will be 1 by 5 delta Br minus upon delta T is equal to 1 by 6 delta H plus by dt. Okay, so delta Br minus by dt is equal to 5 by 6 delta H by dt, delta H plus by dt. So this is the correct answer. Okay, in both cases there was a minus, so that got cancelled. So delta Br by dt is equal to 5 by 6 delta H by dt. Okay, this is dependent on that rate of appearance and disappearance that we discussed in the first class. Are you all understanding something? Hari Raghav, are you there? Sanjay, are you there?
Yes,
Vishal,
ma'am.
are you? Yeah.
Yes, mom.
Is it so difficult to switch on the camera, children? I can't see you. I can't understand what you are doing. Why is it so difficult to switch on the camera? Is your bandwidth not enough? See, if you have so much difficulty in using the camera, children, I think these online classes are no good for you. Really, I'm telling you. Why should you continue with a class where you're not understanding anything? I can't make out whether you are understanding or not understanding. You're just closed camera and behind the camera. So I can make videos and send it to you without your being present in the class, isn't it? If you don't want to communicate with me in the class, what is the point in attending the class? I can send the cameras, you can videos, and you can see them whenever you are free. The good advantage of your being present in the classes, you should be able to say when I'm explaining, ma'am, I didn't understand. Please, can you explain again? I can explain again, but you don't say anything only, so how can I know? Now do this question in case you have understood. Please do the question. Next question. Sanjay, are you there? Sanjay?
Yes, ma'am.
Huh. Do the next question. Rate law for the reaction is given. Concentration of B is doubled, keeping the concentration of A constant. The value of rate constant will, tell me. I am not going to tell you the answer. Will the value of rate constant be doubled, quadrupled, half? What will happen? You are there in the class up to 7 o'clock. At least, Sanjay, you should answer this question if you understood what I am saying. If I change the concentration of B, will the rate constant change? That is the question. Will the rate constant change?
Not the same, ma'am.
It will remain the same because it is a rate constant. Rate constant does not change with change in concentration. There is only one way by which the rate constant will change. How will it change? It only changes with temperature. Okay, so K changes only with temperature. Only with temperature. Okay. Now the next thing, next one, this one. Consider the reaction A changing to B. Concentration of both reactants and products varies exponentially with time. Which of the following figures describes the change in concentration of reactants and products with time? Which one will show change in concentration of reactants and products? Okay, now here you see the, if I look at A, what is A? A is uh, A is a reactant and B is the product. So what is happening? The concentration of the reactant is changing here, right? And the concentration of the product, you see how it is increasing. So when the reactant is minimum, the product is maximum. Can it be possible? It is not possible. Now look at the next next graph. So that as the change concentration is change with time, the concentration of A is decreasing, and with time, the concentration of slowly B is increasing. Okay, so this second one is the correct graph for our question. Okay, second one is the correct graph. Now the next question. The first order reaction is 50% complete in 2.6 into 10 raised to 14 seconds. How much time for it will it take for 100% completion? 50% it is complete in this much time. So that
Ma'am, is
is
it
T
option 2?
half. Uh, we'll have to do it and see. It is 50% completed in how much time will take for 100% come. So first you have, you know, T half. Okay. So T half is 0.693 by K. Okay. So you can find K. So K is equal to 0.693 by 1.26 into 10 raised to 14. That is K. So, so 100% completion, log 100 is log 2. So what much time? So T is equal to 2.303 by K. That is, who gave me the answer?
Ma'am, Hari Raghav.
Sanjay Hari Raghav. How did you do it? Tell me. Can you tell me how you did the question?
Ma'am, in question for 50% there is 1.26, ma'am. So for 100% it will get double, ma'am.
No, it is not like that. It is not always like that. It's not
Okay.
doubled. Huh. So, so now tell me. So here first you have to find the rate constant. Okay, so if it is so rate constant it will be 0.693 by 0.693 divided by 1.226 is equal to 0.55 divided by 10 raised to 14. Okay, then this into so this comes to 5.5 into 10 raised to minus 15 log log. So do the calculation while I am doing it also 2.2, 2.303. 0.6 divided by 5.5. 1.26 into 10 raised to minus. This is the answer. 10 raised to minus 15.
Yes, ma'am.
Okay, you have to do the calculations and then see. Okay, and these are all CBSE questions only. Now look at the next question. Compound A and B react according to the following chemical equation. Okay, concentration of either A or B were changed, keeping the concentration of one of the reactants and rates were measured. So this is the graph given here. We have done this type of questions. Now you have to find what is the rate law. So now you see how will you do this question without actually doing any calculation. So keeping the rate of A constant, what happens when I keep when I double the concentration of this, the rate becomes 4 times. So when I double the rate becomes 4 times, that means with respect to B, it is second order. And then when I keep the rate of B constant and I double the concentration of A, the rate also becomes double. So what is it? The rate law is A, second one, K raised to A and B raised to 2. So most questions are of this type. You should be able to figure out. Now look at the next question. Now this one try, it is the same way as I did the first one. Using in 32 minutes, 75% of the first order was completed. When was 50% of the reaction completed? So first, using the first line, you have to find the rate constant. How will you find the rate constant? K is equal to 2.303 by T log of A0 by A. So what will K be equal to? If I substitute the values, K will be equal to 2.303 by 32 log of 75% of it was completed. So 75% means how much was remaining? 25. So log of 100 by 25. That is log 4. So log 4 is equal to 0.6020. So you will get 2.303 by 32 into 0.6020. So that comes to into 2.303 is equal to divided by 32. So it comes to K becomes equal to 0.43 per second. It was in per minute. Minute minus 1. Now you know the value of K. You can find T half. You know T half is equal to 0.693 by 0.43. So what will that be? 0.693 divided by 0.43. That is equal to 1.6. 0.43 is it? 2.303 into 0.6020 divided by 32. It is 0.04. Okay, this is 0.0463. So the answer will come about 16. So answer is 16 minutes. So when two percentages are given, you have to first find the rate constant using the first line and then find the rate constant using the time using, because the rate constant for the reaction will remain the same. So once you have figured the rate constant, then you can find the T half when 50% of the reaction is completed. So most reactions are of this questions are of the same type. You should get used to them. So reaction between X and Y is first order with respect to X and second order with respect to Y. Okay, so what is the rate law? Rate law is K. First order with respect to X and second order with respect to Y. Right now, what are we doing? If the concentration of X is halved, so X becomes 1 by 2. And what happens to Y? Concentration of Y is doubled. So 2 raised to 2. So what will be the final concentration? How many times will R increase? 1 by 2 into 2 into 2. So it will become double, 2 times. Double the initial value. Answer is double the initial value. Now look at the next question. In reaction N2 plus 3H2, the rate of disappearance of hydrogen is 1.8 into 10 raised to minus 5 moles per liter per second. Therefore, rate of formation of ammonia will be. So first, you look at the reaction. Now we know the rate of this disappearance of hydrogen. So what is the rate of disappearance of hydrogen is 1.8. Now rate of appearance of ammonia. So if I write the rate of reaction in terms of ammonia, what will it be? It will be 1 by 2 into concentration of ammonia by dt will be equal to minus 1 by 3 rate of concentration of hydrogen dt by dt. Now this dH2 by dt I know is 1.8. So what will be the rate of appearance of ammonia? It will be 1 by 2. Let me directly write it. It is NH3 concentration of ammonia by dt will be equal to 2 by 3 into concentration of hydrogen by dt. So that will be equal to 2 by 3 into 1 by 8 into 10 raised to minus 5. So this will get cancelled. It will be 0.6. So what will be the answer? 1.2 into 10 raised to minus 5. So answer again will be B. Hari Raghav, Vishal and Sanjay is something happening? Are you understanding something?
Yes, ma'am.
Sanjay,
Yes,
what is
ma'am.
happening?
Yes, ma'am.
Okay. Now, half-life is independent of the initial concentration of reactants in
Ma'am, can you
which
show that
type of reactant?
before slide, ma'am?
Anyway, do you get to see these slides again
Yes, ma'am.
from the... Okay. Okay, half-life is independent of initial concentration of reactants in what type of reactions? Tell me. So half-life, what is T half? T half for first order reaction. T half is equal to 0.693 by K, right? The initial concentration does not appear in this T half formula. So answer is first order. The first order reaction is independent. Half-life of first order reaction is independent of initial concentration of the reactants. Then for first order reaction, K is 2.5 into 10 raised to minus 1. Then the rate of initial concentration, if the initial concentration is this much, what will be the rate? So what is the rate law? R is equal to K into concentration of A. So I have to find R. I know K. What is K? 2.5 into 10 raised to minus 4. And what is concentration initial? 0.01. So what will R be equal to? 2.5 into 10 raised to minus 6. C. Then for this reaction, if the concentration of NO2 increases by so many moles per liter per second in 100 seconds, then rate of reaction will be. Now, rate of reaction with respect to R, with respect to N2O5, what will it be? It will be change in concentration of NO2. So, it will be 1 by 2 into change in, no, not 1 by 4. It will be 1 by 4 into change in concentration of NO2 d NO2 by dt. So what will it be equal to? 1 by 4 into 5.2 into 10 raised to minus 3 divided by 100. So that will come to how much? 100 seconds. So this will, when it goes up, it will become 10 raised to minus 5, and this will get cancelled. So 1.4 threes are 12. 1.3 into 10 raised to minus 5. It will become 1.3 into 10 raised to minus 5 moles per second. Moles per liter per second. Okay. Now Sanjay has to leave. So before he leaves, let me start something new. Now, so today we are going to do this Arrhenius equation. Okay. Now, Arrhenius equation is an equation which helps us to understand the relation between the rate of reaction and temperature. Okay, so what does this tell me? It tells me the relation between rather rate constant and temperature. Okay. So this was the equation suggested by Arrhenius. So we call it Arrhenius equation. So he suggested this relation between rate constant. How does the rate constant increase with increase in temperature? So if it was found, normally it was found that if I increase the temperature by 10 degrees, the rate constant becomes doubled. The rate constant doubles if the temperature increases by 10 degrees. How was that found? It was found by Arrhenius equation. So what is the Arrhenius equation? The Arrhenius equation is that K is equal to A E raised to minus EA by RT. You have to learn this equation. So what is the Arrhenius equation? K is equal to AE raised to minus EA by RT. Now in this equation, K is equal to the rate constant. Sometimes they only ask you to explain this equation. So what A is the frequency factor. Those who are present in my class, they will understand what I am saying. Frequency factor is how many times the effective collisions take place in order for a product to be formed. The reactant should collide effectively. So how many effective collision, what percentage of molecules are undergoing effective collision for the formation of the product? That is frequency factor. Then EA, I showed you the other day. It is EA is a activation energy. Activation energy. So that is the energy which the molecules, that is the minimum energy the molecules should possess in order to bring about a change in order to change into products. So that is the activation energy. And R is, of course, the gas constant. And T is temperature in Kelvin. In Kelvin. Okay. Now, how do I use this equation to find? First of all, this equation can be used to find, first thing is to find the activation energy. So how do I? So I'll need to simplify this equation. To simplify this equation, I take log on both the sides. So if I have to take the log on both sides, I can say ln K is equal to uh, mine is equal to minus EA by RT plus ln A. Okay, I've taken log on both sides. So this comes here and plus ln A. So this is a simplified format. So this simplified format, I can, plot a graph. This simplified format looks like y is equal to mx plus c. Okay, so if I take it on the other side, another slide, so I'll write it again here. So what is my Arrhenius equation? My Arrhenius equation is ln K is equal to minus EA by RT ln A plus ln A. Okay, so this is equal to y is equal to mx plus c. So if I plot a graph here, if I plot a graph, then what will I take on the y-axis? On the y-axis, I will take ln K. And what will I take on x-axis? 1 by t. 1 by t. And what will be where? So what type of line will I get? Negative slope. This is an equation for a straight line. So for this straight line will have a negative slope, and where this line cuts the y-axis, that point will be ln A. Okay, ln A. And the slope here will be equal to minus EA by R. The slope will be EA by R. So if I draw a graph between the rate log of rate constant, ln K of rate constant and 1 by T, I will get a negative slope, and the slope will help me to find out the activation energy of the reaction. So this is the way I find the activation energy of a reaction. We will do some numericals based on this. So this is type 1. Now the type 2 is also based on this equation only. So let me go to the next slide. So so you see here it is ln. I can write this equation again. So ln k is equal to minus EA by RT plus ln A. Now, if in this graph I take two different temperatures, the values of K are at T1, the value of rate constant is K1, and at T2, the value of rate constant is T2. So I will write two equations. First, ln K1, rate constant at temperature T1 will be equal to minus EA by RT1 plus ln A. And rate constant at K2 at temperature T2 will be K2. So what will I write? Minus EA by RT2 plus ln A. Okay, we are talking of the same graph. So ln A is same. This is equation 1 and this is equation 2. So if I subtracting equation 2 from equation 1, right? I can arrive at another equation. If I do that, I will get ln K2 minus ln A1 K1 will be equal to, I will subtract this one from the other one. So I will minus EA by RT2 plus ln A minus, this will become plus. So minus EA by RT1 plus ln A, right? When I open this graph, then what will happen? If I open the graph, I'll show you here itself. So on opening the graph, this will become plus and this will become minus, right? So I'll do that. I'll make this as plus and this as minus. So this and this will get cancelled. So I can rewrite this ln K2 by K1. Log of A minus log of B is equal to log of A by B. So ln K2 by K1 will be equal to minus, I'll bring this whole thing front. So it will become minus EA by R in bracket 1 upon T1 minus 1 upon T2. T1 minus 1 upon T2. So this is the equation number 3, which also we can use to solve a few questions. Okay, so we are going to try to solve a few questions now based on this. Okay, so how do we do that? The rate constant of a reaction at 500 and 700 K are 0.02 per 0.02 per second and 0.07 per second. Calculate the values of EA and A. How will we do this question? Okay, so now the two temperatures are given and two rate constants are given, right? So we can easily find the value of A. What is the formula that we will use? ln K2 by K1 is equal to EA by R 1 upon T1 minus 1 upon T2. Okay, now substitute the values. So what are the values we have? So I can put the values of K2. So now instead of keeping it in ln, I can change it into log. So I can rewrite this equation as log of K2 by K1 is equal to EA upon 2.303 into R, right? 1 upon T1 minus 1 upon T2. So now put the values. Log of 0.07 divided by log of 0.02 is equal to EA, I have to calculate, upon 2.303. Value of R is 8.314. 1 upon T1, temperature 500. 1 upon 500 minus 1 upon 700. Okay. Now this is a little heavy on calculation. So I have done the calculation and I am showing it to you. So this value, log of 0.07 to divided by 0.02, it comes to 0.544. That is equal to EA by 2.303 into 8.314, and we'll calculate the what is inside the bracket first. So you have to take a LCM here. So it will be 500 into 700, and on the top 700 minus 500. All right. So if I do all those calculations, my answer comes to EA will be equal to 18230.8 joules. And you divide it by 1000, so it will become 18.2 kilojoules. You can do it in joules itself because the value of R will remain in joules. So you can use this value. This is the answer for EA, activation energy, right? And such questions do come in the exam. This sort of calculations you will have to do in order to get. Now the next part of it is you have to calculate the value of A. You have to use Arrhenius equation, but I don't think those questions are in your syllabus. I have to confirm. So if I have to find the value of A, how will I find? Control M. So K is equal to A E raised to minus EA by RT. So one way of doing it is I can convert it into log and do it. Otherwise, I can just do directly 0.02 is equal to A E raised to minus all that big value 18230.8 divided by 8.314 EA by RT. Temperature is 500 into 500. So calculating this is a challenging problem. Okay. So if you are able to calculate this, your answer should come. It will come to, I'll have to show you some easy way of calculating. I do the calculation by calculator, You can do log values. Some values are given in the exam, but in case you are not able to do the whole thing in the exam, then you should at least fill the values, substitute the values and do it. Here the value of A comes to 1.61. So right now I did not calculate the way I should show it to you using log. I'll show you how it has to be done in the exam. I used a calculator so I could get the answer easily. So the second part of the question, for the time being, you leave it. We can learn how to do it in the tomorrow's class. Let us do one more question here. The first order rate constant. First order rate constant for the decomposition of ethyl iodide is given here. So C2H5I gaseous giving this. At 600 is given here. The energy of activation is also given. Calculate the rate constant of the reaction. So how will you do this one? In this question, first order rate constant is given at 600. So you have to do the same thing, only calculation will be a little. So here again we have to do, we can write log K2 minus log K1. We will write it separately, is equal to EA upon 2.303 into R and 1 upon T1 minus 1 upon T2. Okay, so we have to find log K2. So log K2 will be equal to log of log K1 plus EA upon 2.303 R 1 upon T1 by 1 upon T2. 1 upon T2. So now fill in the values and do it. So what will you get? It will be log K2 will be equal to log of K1 is given 1.6 into 10 raised to minus 5 plus EA by the whole thing. So EA is given as 2.09 kilojoules. So I have to convert it into joules because value of R is given in joules only. So it is 290 into 1000, so 000 divided by 2.303 into R 8.314, and this one here is 1 upon I know the one temperature is 600 minus 1 upon 700. So doing all this calculation, you will be able to get the value of log K2. So log K2, you will be able to find out. And once you know the value here, you have to take the anti-log. Okay, so that is why these reactions are a little intensive. So what I'll do is by tomorrow, I will give you the anti-log values, because in the exam you are not expected to find out, but the value of log K, anti-log value of this one will be given to you. So if you can reach this level, you will get full marks. So you should be able to substitute it correctly. So if you are able to substitute, then the react. Otherwise, these questions or reactions, such questions require a lot of practice in calculations, which is a mathematical part of it. So that mathematics of it, if you know it well, then there is no problem. I am a little, I find it a little difficult to explain mathematics, especially when you are behind the camera. I don't know how to explain. So try it out yourself. if you are comfortable using without a calculator, because in the exam you will have to do the calculator. I can only tell you the answer here. The answer comes to 6.36 into 10 raised to minus 3 per second. So if you are able to do it without a calculator, very good. Otherwise, use a calculator and see whether you can get such an answer. Okay. So that is about doing these questions with. Okay, now Sanjay has also gone.
No, ma'am, I'm here.
Now, Sanjay, you are there? You
Yes.
said you have to. Who is gone then? Hari Raghav is gone. So, so this is the last part of this chapter. Do you want me to explain something again to you? Anything that you want to explain? This is the last part of the chapter. Pseudo unimolecular, pseudo first order reactions. Okay. So, in the last class, Sanjay, were you there when I was talking about molecularity of a reaction?
Uh,
Okay. So, this is the last part of this chapter. So, what is pseudo first order reaction? So, there are a few reactions like, I'll take a few examples. One is the reaction of hydrolysis of esters. It is known as hydrolysis of esters. Okay. So, ester, you know what is ester CH3 COO C2H5. This is an ester. And if I react it with water, what do I get? I get CH3 COOH plus C2H5OH. Okay, in presence of a concentrated H2SO4. This reaction is known as hydrolysis of esters. And this is an elementary reaction. Elementary reactions, I told you, are those where the order and molecularity of the reaction is same. So if it is an elementary reaction, first of all, look at the reaction and tell me what is the molecularity of the reaction. What is the meaning of molecularity? I told you it is the number of molecules which take part in a reaction, which you can make out by looking at a balanced chemical equation. So in this case, one molecule of ester requires one molecule of water for hydrolysis. So unless there is water, hydrolysis will not take place. So by looking at this reaction, you can say molecularity of this reaction, molecularity is equal to 2, right? Molecularity of this reaction is 2. But when we look at the order of the reaction, then you will realize that if I take water is in large excess and only very little of the water takes part in the reaction, and as a result what happens is that the concentration of the reactant water remains literally unchanged. So although it is a bimolecular reaction where the order of the reaction should be 2, but when I calculate, the order of the reaction appears to be 1. So such bimolecular reactions, such bimolecular reactions which are elementary, but actually they are first ordered because the second reactant is in large excess. They are known as pseudo first order reaction. Okay, so what did I, explain the other day? I told you that if there's a reaction A plus B giving C, then, and it is, if it is a elementary reactions are which one? Where the order and molecularity of the reaction is same, or the reaction takes place in a single step. There are no multiple steps. So for such reaction, molecularity is equal to molecularity is equal to 2. Why? One of this and one of this. And order of this reaction will also be 2. So order of the reaction will, in this case, you can assess by just looking at the reaction. The order of the reaction will be same as molecularity of the reaction. So this is a this is how you identify a elementary reaction. But there are certain reactions where molecularity is 2, but the order is 1. Why is the order 1 for this reaction? It appears to be first order reaction because the concentration of water does not change much. Although the presence of water is required, the reaction cannot take place without water. But since water is in large excess, the concentration of water hardly changes, and such reactions are known as pseudo first order reactions. So there are only two examples of such reactions. First is hydrolysis of esters, and the second such reaction is known as inversion of cane sugar. Inversion of cane sugar. Okay, so what is cane sugar? Cane sugar is C12H22O11. When I reacted with water in the same way, compared to the concentration of sugar, water is in large excess, and the concentration of water does not change as a result of the reaction. So change in concentration of water is negligible. So we can say, so what do you get? C6H12O6 plus C6H12O6. These two are, one is glucose and the other is fructose. Okay, this reaction takes place in the presence of an enzyme which is called invertase. That doesn't matter, that's not important. What is important is this is also an elementary reaction. And in an elementary reaction, molecularity is what you simple reaction. You can see what is the molecularity, number of molecules present in the balanced equation. So there are 2 molecules of reactant, so molecularity is 2. Order of this reaction is 1. Why the order of reaction is 1? The order is 1 because the rate of change, the change in concentration of water is negligible. So we can say the rate of reaction depends only on the concentration of sucrose and not on the concentration of water. So order is 1, molecularity is 2, and it is elementary reaction. So it is called what again? Pseudo first order reaction. First order reaction. Right? If there is a reaction which is uh, where order and molecularity are different, then it is most other reactions where order and molecularity are different. They are not elementary reactions. They are complex reactions. They do not take place in a single step. So if order and molecularity are different, then the reactions are generally uh, complex reactions, except these two, which are elementary reactions, and still their order and molecularity are different. So that is pseudo unimolecular reaction. Now in this chapter, at the end of the chapter, there are numerous questions which are given. So I want you all, both of you, just see how to solve these questions. So we'll have to learn how to solve these questions. And once you are a little confident, because this chapter is not so easy, it is a little difficult. Every step you have to understand properly. So what I'll do now is I'm going to just quickly take 5 minutes more and then we will stop. Thank you for remaining till the end of the class. I'm just going to write all the formulae that we need to use in this chapter. So the first formula, these are formulae for kinetics. The first formula is rate of, what is the rate of reaction? R is equal to uh, change in concentration of, you can write it like this, change rate of reaction. I should also make it So rate of reaction is equal to change in concentration of reactant or product. Change in concentration of reactant or product divided by change in time. Right? And this is which type of rate of reaction? This is average rate of reaction. So if I just take the initial concentration and final and initial and see the final time and initial time, I calculate the average rate of reaction. Then the second is rate, instantaneous rate. Instantaneous rate is minus dA by dt. If there's only one reactant, minus dA by dt. Then the third thing that we learn is rate law. Rate law is equal to K A, concentration of A into concentration of B, X and Y. And order of reaction for the above reaction, order is equal to X plus Y. Okay. Then we learned about T is equal to, for the first order reaction, T is equal to 2.303 by K log of A0 by A. What is A0? Initial concentration, and A is the concentration after time T. This is for first order. Right? Then the next one, sixth one. The sixth formula that we use is T half is equal to 0.693 by K. Yes?
Now, can you show that previous statement?
Yes. Then for seventh formula that we need to learn is for zero order reaction. Okay. For zero order reaction, T is equal to A0 minus A upon K. This is for zero order. This one is for first order. Then eighth is T half. T half is equal to A0 upon 2K. This is for zero order. Then ninth equation that we learned was for finding the units of rate constant. So unit of rate constant, that is equal to moles per liter raised to 1 minus n and s minus 1. Okay, time minus 1. So n is the order of reaction. And the last one that we learned is this one, log K2 by K1 is equal to EA by 2.303 R and 1 upon T1 minus 1 upon T2. So these are the 10 equations. So kinetics is if you are good in maths, kinetics is very easy. If you are not good in maths, kinetics is difficult. Actually, I am not good in maths. That's why I take a little longer in doing the calculations. So if you are good in maths, you should try out all these reactions, try out all these uh, mm, first learn the formula and do all the questions from the textbook. That's the only way of doing well in kinetics. Okay. So we have done quite a few of MCQs. Anyway, you will get to see all these equations. One more thing, remember the graphs. Just last bit, I'll tell you the three graphs that you use for this kinetics, the three graphs that you should be able to understand. Okay, several graphs are there. So I will show you all the graphs together. The first graph is for first order. So first order reaction, what is the graph? It is uh, so if I draw the graph between time t and ln A, okay, then it will be a negative slope. And the slope of the graph will be equal to minus k. Okay, the slope of the graph will be equal to minus k. This is first order. And for zero order reaction, it's a similar graph between T and A. Right? If I draw the same graph between T and A, this. So this will be negative slope. And here also slope will be equal to minus k. Okay, so if the graph is between ln A and T, the slope will be of the first order reaction. If it is between concentration and time, then slope will be of the zero order reaction. Then the next type of graphs that you should know, two more graphs. The next graph is of Arrhenius equation. If I draw the graph between 1 by T and log of K, right? Then I get a negative slope. And here the slope is of the graph is minus EA by 2.303 R. All right, so that will be the slope. Then there is one more graph which is often asked, and this graph is showing, this is Maxwell-Boltzmann graphs. Maxwell-Boltzmann graph. Okay, and in this graph, here it is energy, and here it is the fraction of molecules which have a particular energy. So this is a graph at a particular temperature T1, and when I increase the temperature to T2, right? This is how you draw the graph, and this is EA, activation energy. So when I increase the temperature, the number of molecules which are able to cross the activation energy, it increases. So this is another graph which you should understand. If any of these things you don't understand, please go over it and tell me tomorrow. We will explain it once again. Otherwise, tomorrow I'm going to start a new topic. I'm not going to waste time because there is little time remaining. By October, we have to finish all the syllabus. So in tomorrow's class, I'm going to start with, have we done aldehydes and ketones? Hari Raghav,
No,
have we done aldehydes and ketones? Have we done?
I guess no, ma'am.
Okay, so tomorrow I'm going to start aldehydes and ketones. Okay. So see you tomorrow. Hopefully there'll be better attendance. Okay.
Yes.
Yes, ma'am.
Thank you,
Thank
ma'am.
you.
You're welcome.
Thank you, ma'am.
Vishal, gone. Sanjay, bye. Thank you for staying till the end of the
Thank
class.
you, ma'am. Thank you, ma'am.